Hi, welcome to Nomis Academy. This time we'll be dealing with perimeter of segments. Yes, perimeter, also known as circumference. This time we're talking about segments. Remember what a segment is. What a segment is. A segment is simply a a, a part of a circle when a circle is divided by a chord. I take that again. A segment is a part of circle when the circle is divided into unequal parts by a chord. Remember what a chord is. A chord is a length of line that divides a circle into two unequal parts. And I have told you that when a line divides a circle to two equal parts, it does not pass the center of the circle, and that line is known as a chord. So let us bring it into our remembrance to understand this. How do I now learn the perimeter of segments? This is a segment. Looking at this shape, looking at this circle here, you can see a segment is bounded by an arc and a chord. A segment is bounded by an arc and a chord. An arc and a chord. So if I will need to get the perimeter of a segment, that means I will just have to add the length of the arc and the length of the chord. So let's look into that. There are formulas that you can use to calculate the perimeter of a segment. You can decide to calculate the perimeter of the sector and subtract the perimeter of this triangle out of it. Then you get to know the perimeter of the segment. But to make it simpler, let's take it this way. Calculate the perimeter of the arc and the perimeter of the chord. Then you get the perimeter of the segment. So let us recall that the perimeter of an arc, remember, people making noise. So there are many formulas to calculate perimeter of a segment. One can decide to calculate the perimeter of the sector and subtract the perimeter of this triangle out of it. Then you get the perimeter of this segment. Now, let's take it this way. The length of the chord and the length of the arc should give me the perimeter of the segment. So we're going to recall that the length of an arc is 2 pi r open bracket theta all over 360. For this is the part of the circumference of a circle that is occupied by that segment. So length of an arc is equal to 2 pi r open bracket theta all over 360. Why the length of chord? Length of chord is equal to two r sine theta divided by 2. So this is the length for a chord. So to calculate the length of a chord, 2r sine theta divided by 2. The length of an arc is 2 pi r theta all over 360. So the addition of this length gives me the perimeter of a segment. Therefore, I can now tell that the perimeter of a segment is equal to length of an arc plus length of a chord. So length of an arc says 2 pi r open bracket 3 is theta all over 360, now plus 2r sine theta all over 2. So let us take an example to calculate the perimeter of a segment. So let's calculate the perimeter of this segment. Let's calculate for the major segment and the minor segment. So example number 1, calculate the perimeter of the Roman figure 1 minor segment, Roman figure 2 major segment. Kabiru, you not hear word o. Now the solution. Now the solution. The minor segment. For the minor segment, I told you first thing, perimeter of segments has to be used here is equals to 2 pi r open bracket theta all over 360 plus 2r sine theta all over 2. So let's put in the value of our parameters. We know what pi, we know the radius, and we know the theta. So 2 over 1 multiplied by 22 over 7 multiplied by the radius, which is 21 over 1 multiplied by our theta is 60 all over 360 plus 2 over 1 multiplied by 21 over 1 multiplied by sine 60 over 2. So with this, we can say we have 2 times 22 should give us 44. So over 1 multiplied by, because 7 here 1, 7 here 3, I should be left with 3 over 1 multiplied by, this is 1 over 660 over 360 is 1 over 6, 1 over 6 plus 2 times 21 is 42 over 1 multiplied by sine 60 over 2 is sine 30, sine 30. So this is 44 multiplied by 33 is 132. Now divide by 6 plus 42 multiplied by sine 30 is 0.5. 132 divided by 6, 6 here 1, 6 in 13 is 2, remainder 1, 6 in 12 is 2. So plus 42 multiplied by 0.5. See, when you are asked to multiply anything by half, remember that 0.5 means half, 1 over 2. So you are going to divide that number by 2. So 42 multiplied by 0.5 is 21. So we can tell that 22 plus 21 is 43. So the perimeter of the minor segment that we are seeing here is 43 centimeter. So let's calculate for major segment. The major segment. So we just tell that perimeter of segment is equal to 2 pi r open bracket theta all over 360 plus 2r sine theta all over 2. So we can put in the parameters. 2 over 1 multiplied by 22 over 7 multiplied by the radius 21 over 1 multiplied by the theta is 60 all over 360 plus 2 over 1 multiplied by 21 over 1 multiplied by sine theta is 60 divided by 2. No, this is correct. This is wrong. So let us put in the value of our parameters. 2 over 1 multiplied by 22 over 7 multiplied by 21 over 1 multiplied by theta. What is theta here? Remember that we are dealing with major segments here, and the minor segment has taken 60 degrees, meaning that the major segment will take about 300 and we take about 300 degree. Take about 300 degree. So 300 over 360 plus 2r, okay, 2 over 1, 2 over 1 multiplied by 21 over 1 multiplied by sine 300 divided by 2. So we are going to have 44, 2 times 22, 44 over 1, 7 here 1, 7 here 3, so multiply by 3 over 1, multiply by, so 0 cancel 0, 6 here 5, 6 here 6, so plus, we have 2 times 21, so that's 42 over 1 multiplied by sine 150. So I can tell that 3 here 1, 3 here 2, right? 3 here, so I can tell that 3 here 1, 3 here 2. So 2 here 1, 2 here 22. So I'm left with 22 multiplied by 5 plus 42 multiplied by sine 150. Sine 150 equals to 0.5. So this is 110 plus 42 times 0.5, which is half, is 21. 21. So 110 plus 21 gives us 131 centimeter. So the area of the major segment, so the perimeter of the major segment is equal to 131 centimeter. I hope you understood all that we did in this video. Bye bye. See you in the next video.